logarithm base a. So now we're going to do logs in any base. And to do that, we got to know the relationship between logs and exponential functions. So let's write an exponential function first. So b to the x equals y. That's my exponential function. And the most important part about this is right here. That is called the base of an exponential. Right? This is the exponent, this is the solution, that's the base. Now if I write this as a log, all we're going to do is that base, when we write a log, you see right here, that number right there is also called the base. And that's the key to this. If you want to rewrite it, you got to find the base. So base here, it's going to go down here. And what we're going to do is this. The base to the answer equals the power. So log base b of y equals x. That's how you rewrite it. You have to find the base to the answer equals the power. And if you want to go the opposite way, so this is if you want to go exponential to log. If you want to go the opposite way, you want to go from a log to an exponential. It's the same thing. Find the base. My base is b. So you go, okay, b to the answer equals that number right there. So now that we have that, let's do an example. Write an equivalent exponent statement for log base 10 of 1,000 equals 3. So we can do a first. So all about the base, right? Find the base. Base is 10. 10 to the third equals 1,000. Done. B. Write equivalent log statement for this. So 3 to the 4 equals a1. We want to write that as a log. Same idea. Find the base first. So you write log. It's my base, 3. 3 to the 81 equals 4. Remember, that's the way logs work. It's basically saying 3 to what power equals 81. And 3 to the 4th power equals 81. Now let's solve the log. So there's a couple ways to evaluate these logs. One way is to go, okay, 2 to what power equals 16. That's always way 1. 2 to what power, what are the bases, equals 16. If you answer the question, you have the answer. In this case, that would be 4. 2 to the 4th equals 16. Another way to do it, it's kind of the same idea, is you want to rewrite this. We want to have the bases match. If you can rewrite the log so the bases match, then we can move this k to the front. You get k log base b of b. These would cancel, and you just get k. So like in this case, if I write 16 as 2 to the 4th, then I can move the 4 to the front, and I get 4 log 2 of 2, which is just 4. Right, so it's the same idea. Either way, you gotta know your powers. My answer here is 4. How about the next one? I want to rewrite 0.2 as a fraction. So this is log base 5 of 0.2, which is the same thing as saying 2 over 10. So let's reduce that. It's log base 5 of 1 over 5. Right, so I could say 5 to what power equals 1 over 5, and you can think about it, and it should be negative 1 because I gotta flip the power. Or, go, okay, I gotta flip this up because they don't match. So this is going to be log base 5 to the negative 1 power. Right? When you flip it, it makes the power negative 1. Hey, these match. You can bring the negative 1 to the front. These will cancel out, and you get negative 1. Next one. Got some space here. Right? So we have to rewrite this. This is log 10. I'm going to rewrite the 100 first. Remember, we want these to match. So 100 standing is saying 10 squared. So the 5th root of 10 squared. And then you can rewrite this. The 5th root sitting is saying 2 over 5. So log base 10 of 10 to the 2 over 5. Remember, the power always stays. The root is what could change. Not the power stays, root changes. So I get this. These cancel. You just get 2 to the 5th. Technically moving 2 to the 5th to the front, and it multiplies to get 1, but same idea. And the last one here. So I'm going to rewrite it. It's log base 2 of 1 over 2 to the 1/2 power. I square root is 1/2. Now I can move this to the top. And I get 2 to the negative 1/2. Then right here you can move the negative 1 to the front, and these cancel out, so you just get negative 1/2. So that's one way to simplify logs. You can either ask yourself, okay, 2 to what power equals 16, or if you're having a hard time with that, try to make the bases match and cancel at the top. So we're going to try to find these without a calculator. Log base 8 of 2. So again, you can ask yourself, 8 to what power equals 2? And the other thing about it, kind of funky, it's a cube root. Cube root of 8 equals 2, which would be 1/3 power. But another way of doing this, that people always like, is one way to do is to set equal to x, rewrite and solve. So there's always a way to do logs. One way, the most basic true method is you go this to what power equals this. And you can figure it out, you got your answer. Another way is try to make the bases match, like we did here. We did a lot of that there. And a third way is just set equal to x and rewrite it. So you get that and you go, okay. Remember how do we rewrite this? You go 8 to what power? 8 to the x equals 2. And then we solve it like we used to do it, like we solved exponential equations in the past. You go, I try to make these the same base. So this is 2 to the third. X equals 2 to the first. Solve the powers. 3x equals 1. X equals 1/3. Right, which is the same thing I said from the very start. It's 8 to the 1/3 power equals 2 because the cube root of 8 equals 2. So lots of ways to solve it. This one looks like it's easy to try to get the same base. So I'm going to have to rewrite this one to be 6 times 6 to the 1/2. Right? So 6 to the 1/2, that's 6. Now you could add the powers and you get 6 to the 3/2. So we have log base 6, 6 to the 3/2. Well, these match, so I can cancel out. You move the 3/2 to the front, you just get 3/2. Next one, 3 to what power equals 1 over 27, the square root of 27. So another one, I'm going to try to make the bases match. That wasn't really possible with the first one here. I'm going to do that here. So I'm going to write this as 1 over 3 cubed, square root of that. It's a little thick. So it's going to be 1 over 3 cubed, and there's still a square root. Remember the way you rewrite square root? It's the root. The root changes, the power never changes. So this is 3 to 3/2. On the bottom, actually. It's underneath the fraction. And then we can move it to the top. So I get 1 over, I get 3 to the negative 3/2. So I just rewrote all this right here, right? All this was 1 over 3 cubed, square root of 3 cubed, then it was 1 over 3/2. Then you move it to the top and you get 3 to the negative 3/2. This side's still here. It's log base 3 of all this. Well, notice these match again. So they're going to cancel out and you just get negative 3/2. Now this one, I'm not going to make these bases the same, but don't forget our first rule. You just tell yourself, 4 to what power equals 1. If you think about it, it should come to you. But we'll solve it this first way here. We'll set equal to x and we'll solve it. Set equal to x, right? And then you rewrite it. 4 to what power equals this. 4 to the x equals 1. 4 to what power equals 1? 0. Anything to the 0 power equals 1. So my answer to this one's just 0. Anytime you see a log with a 1 as the primary number, then it's a 0. Lastly, simplify each. Log base x of x. So remember, all we have to do here is try to get these bases to match. I rewrite this as log base x, x to the 1/2. Once they match, you technically bring this to the front, and you get 1/2 log base x of x, which cancel out, you just get 1/2. Over here, how do we solve this? Log base 3 of x equals 5. So one way we could rewrite it, like we talked about earlier. Another way is this, whatever the base is, you take that to both sides. That's the way we're mostly going to solve logs. Whatever the base is, you take it to both sides. These cancel out, and you get x equals 3 to the 5th. And there we go.